So good afternoon in Indonesia, ladies and gentlemen. I am Dzikrie Syah from Institute Teknologi 10 November, Indonesia. It is truly an honor and pleasure to present my research at this event. I'd like to express my sincere gratitude to Professor Eka Putri and Professor Fujiyama for their efforts in supervising me as I worked on this research. The title of this presentation will be Utilization of High Volume Sidoarjo Mud as a Cement Replacement in Concrete. I'm hoping that my presentation and research will aid in the creation of environmentally friendly building materials and help find a way to save the ecosystem of the Porong River. So Sidoarjo mud, or Lucy afterwards, is volcanic mud that erupted from the earth because of an accident while drilling a gas well. The resulting mud was dammed by an embankment. Over time, the embankment became filled, prompting the authorities to take action to drain the mud into the Porong River. The implication of dumping Lucy into the Porong River are that the ecosystem of Porong River is disrupted. Not only the ecosystem, but also the river itself becomes damaged by river silting, river narrowing, and also river deltas. So the aim of this research is to replace as much cement as possible with Lucy combined with calcium carbonate and ground granulated blast furnace slag, or GGBFS. While maintaining the mechanical properties of concrete. The fact that no studies have been done combining these three materials emphasizes how important this research is. The hypothesis of this study is that the resulting concrete has a lower strength, worse shrinkage, and worse workability, but a longer setting time, a lower hydration temperature, and increase in packing density. This research is separated into two sections, the base variation and the concrete variation. There are 6 variations of base specimen. Normal as a control specimen and starting from 50 to 70% of cement replacement. So the first 2 digits in here is showing the percentage of Lucy that replaces cement. The letter L denotes Lucy, the letter C denotes additional 5% calcium carbonate. The letter N denotes that some of the water has been replaced with natrium hydroxide solution. And the letter S denotes an additional 5% GGBFS. The tests carried out were setting time test, pH test, compressive strength test, and porosity test. After that, 3 variations have been selected based on 28 days base compressive strength to make them on concrete specimen. The tests carried out were setting time test, slump test, hydration temperature test, autogenous shrinkage test, compressive strength test, and splitting tensile strength test. This is the first result of my study. In terms of the base compressive strength, it is known that replacing cement with Lucy results in a decrease in compressive strength. You can see it in here from normal variation to 50L. It is known that replacing, which is obviously caused by a decrease in cement content. The use of calcium carbonate, GGBFS, and natrium hydroxide solution showed a good trend in that it could increase the compressive strength. We can see it in 28 days base compressive strength from 50L to 60 LCSN. We can see it that variation such as 50 LCN and 60 LCSN has a strength activity index of more than 75%. And it should be noted that none of the variation of Lucy compressive strengths are comparable to or even higher than those of the normal variation. And next is the concrete compressive strength test. The result of concrete compressive strength test showing that the Lucy variant has a good early strength in 7 days. Although the Lucy-containing concrete exhibits high early strength, its compressive strength is lower than that of the normal specimen after 28 days. However, all variations had achieved the targeted compressive strength of 30 megapascals. There was no noticeable difference in age from 28 days to 56 days, which indicates that the concrete mixture has run out of materials to hydrate. So if we recall the base compressive strength at 7 days or 28 days, none of the variation compressive strengths are comparable to or even higher than those of the normal variation. This may raise a question: how could the concrete have good compressive strength? It's to say there is a factor involving aggregates that results in the good compressive strength of concrete. As we know, normal strength concrete failure occurs in the bond between the cement matrix and aggregate, which is known as the interfacial transition zone, or ITZ. And this figure was taken using a micro camera that showing that the Lucy ITZ is about the same as the normal or cement ITZ. And since this mechanism also applies to the normal variety, the compressive strength of the Lucy variant is almost the same as the normal variety. And then the splitting tensile strength of the Lucy variation follows the same trend as the compressive strength. The splitting tensile strength of the Lucy variant was decreased. This image also shows that the failure was caused by a loose bond between the cement matrix and the aggregate. And last, this is the result of concrete hydration temperature and autogenous shrinkage test. The hydration temperature test was conducted within the first 24 hours after the concrete was cast, while the autogenous shrinkage test was conducted until 10 days of age. So the thermocouple data show a decrease in the hydration temperature in the Lucy variation due to the lower cement content, which is the primary source of heat. Surprisingly, Lucy's concrete has less autogenous shrinkage. There are two reasons for achieving this result. First, an improved early strength offered a support in order to restrain the shrinkage. And second, the relatively small particle size of Lucy, calcium carbonate, and GBFS results in a higher packing density. And from the result that has been presented, it can be inferred that the reduction of base compressive strength is caused by less cement content. And the concrete containing Lucy has good strength due to a good ITZ. The third, the hydration temperature of the Lucy containing variant decreases due to a decrease in cement in the concrete mix. The Lucy containing variant's shrinkage has decreased as a result of improved early strength and a higher packing density. I think that's my presentation. Thanks for the attention.
Thank you so much, Dzikrie, for your presentation and for your good work. I will first give the word to someone who has any question about or any doubt about this presentation. Go ahead, Motu. Please.
Yes, Dzikrie, thank you very much for your interesting presentation. Your research is very important to utilize Lucy, which is very good in terms of sustainability aspect of concrete engineering. And I have a quick question about curing conditions of your specimen series. What kind of curings did you use?
So this is the curing method. For the paste specimen, the curing is accomplished by wrapping the paste in a moist cloth and sealing it in a plastic Ziploc bag.
I see.
And
I see.
For the concrete curing is accomplished by wrapping the concrete in a moist cloth and placing it in a closed room.
Okay, so curing condition is good enough. Okay,
yeah.
Then can you show me the slide number 5 again? Like a strength development of each series. Yes, yes. To me, it seems like the series with Lucy replacement, still the strength still keeps increasing even after 56 days, while the normal cement looks like have a stable value after, I mean, constant value after 28 days. But what if you measure like 90 days or longer age for these kind of specimen? Will they be like similar to the OPC series, or yeah? So yeah.
Unfortunately, I don't have a time to make the 90 days specimen, so I have no result for a longer time than 56 days.
Especially the 50L series, like significantly keeps increasing, and if you find like the strength can be almost equivalent to the OPC series at the longer age, then people just have to consider, you know, the appropriate applications for this kind of material, and there will be no problems in terms of the strength. Just comment. Thank you very much.
Thank you. Thank you.
So, Graham.
Hi. Can you hear me?
Yes.
Yes, great. That was a great presentation, I thought. Thank you. I was wondering where you were seeing the sort of most likely use for this. Is it as a material that could generally be used, or just as a sort of opportunity to use up this mud that's been deposited accidentally? And do you see this as a useful material to use in kind of to go looking for to use?
Yeah, I think we can use this type of concrete in a structure that doesn't need a fast strength, like a 28 days or 7 days strength, high strength. We can use it as a material in a that need that could use a long time compressive strength development, such as dam structure maybe, or seawater protection in a like in a beach, or what to protect the island.
I imagine the reduced hydration temperature could be helpful sometimes as well in cases where early thermal cracking is a problem or a risk.
Yeah, the hydration temperature shows that the Luciferian decrease in hydration temperature in the peak of the hydration temperature about 9% to 10% compared to the normal variation. It is good to use it in a mass concrete, such as maybe in a raft condition, or a foundation, or the pillar of a bridge, that a big bridge.
Okay.
Thank you.
Thank you, Graham, for your intervention. Ahmed.
Yeah, thank you for this nice presentation, and it's really interesting topic to participate in low carbon concrete. So my question is, let's start from the end. You just mentioned this concrete, or this mix could be good for mass concrete. So I'm wondering, do you think about it, how it will chemically composite with reinforced concrete, with the reinforcement, how it will react, the possibility for corrosion, the chemical composition? Did you have any thought about, or any test related to this?
The chemical composition of Lucy. There is no harmful chemical in Lucy. So the Lucy is just like a fly ash. The composition is just like a fly ash. There is no chloride or chloride ion or any other harmful compound found in Lucy. But Lucy naturally more absorbent than fly ash. So the water content should be increased very high. So we can use it as a cement replacement in high strength concrete. It would be very hard to control the workability of the concrete.
How much you thought about for high strength concrete? I see the results. It's good result, but it's comparing with the normal one, it's lower. So how much you thought could replace to have high strength concrete? I know you did not test it, but just your thoughts about it.
I think the Lucy replacement would be based around 15% to 25%. More than that will be need more water to work with the concrete.
Okay, so if you have the possibility to improve this mix for example for further research, you could use between 25 to 50% replacement.
Yeah, there is a chance where we can use this Lucy just like fly ash in a mass production or in batching plant or anything that concrete.
Yeah. Just the last question. Did you have the measure for the density? So did you compare the density of this concrete compared with the normal one?
Yeah, I do have, but I'm not in my presentation. So let me see.
Yeah. So is it higher or lower than for density comparing with the normal one?
So this is the volume. It's lower. So normal for 2.5 and the 50 for 2.4.
Yeah, because I remember I read a paper about Lucy and they use it for lightweight concrete. That's why I'm interested what the result you had.
The result is the weight volume is almost the same with the normal variation. Okay. Only a bit in a decrease, a bit less.
Yeah. Thank you very much. That's all.